Question 3 concerns a bungee jumper. There's a diagram giving various dimensions of the jump, and the bungee jumper has a mass of 58 kilograms. In A part 1, assuming the centre of mass of the student has fallen to a vertical distance of 25 meters when she reaches point P, we need to find her speed at P, assuming air resistance is negligible. Well, the gravitational energy lost will equal the kinetic energy gained. So mg delta h, the gravitational potential energy, will equal mv squared over 2, the kinetic energy. Rearranging for v, we can then add the values, and this gives a speed of 22 meters per second. In part 2, the cord behaves like a spring with spring constant 54 newtons per meter. We need to find the distance d from P to Q, assuming the cord obeys Hooke's law. Well, force is equal to spring constant times change in length. So rearranging for change in length, the force is the weight of the student, which is 58 kilograms of mass times 9.81 newtons per kilogram, gives a change in length of 11 meters. In B, as the student moves below P, she begins to move with simple harmonic motion for part of an oscillation. In part 1, if the arrangement can be assumed to act as a mass spring system, we need to find the time taken for half an oscillation. Well, for a mass spring system, the time period is 2 pi root mass over spring constant, and this comes out at 6.5 seconds. We want half a time period, which is 3.3 seconds. In part 2, we need to use our answers from parts A and B1 to show that the amplitude, the distance from Q to R, is about 25 meters. Well, frequency is 1 over time period, and this is 0.15 Hertz. When x is 10.5 meters, we found previously that the speed is 22.1 meters per second, and so using this equation, we can square both sides, rearrange for the amplitude, putting in all the values gives 25.1 meters, which is around 25 meters as required. In C, we need to explain why, when the student rises above P, her motion is no longer simple harmonic. When the rider is above P, the rope is no longer under tension, so the force down is just that due to gravity. This is a constant. For simple harmonic motion, the force must be directly proportional to displacement. In D part 1, we're asked where the student is when the stress in the bungee cord is a maximum. Well, this is when the rider is at the lowest point. In part 2, the bungee cord has a significant mass. Whereabouts along the bungee cord is the stress a maximum, explaining our answer. Well, the stress will be a maximum at the top of the rope, as this point supports the entire mass of the rope, and stress is equal to force over area.